Yes, you're most welcome once again to my YouTube channel. It is still your tutor Peter Ekaja as usual. And in this tutorial, I'm going to be taking you through more of the examples on integration by parts. Remember, we started this in the previous tutorial, and these are just additional examples to help you get the principles and expose yourself more onto questions that require integration by parts. Now, let's look at this first example here. It says we find the integral of x sine x with respect to x. The first thing to go back to is what we talked about in the previous video. We talked about Laerte. And we said the letter that comes first represents what we shall let to be u. And when you look at this, x is an algebraic expression and sine x is a trigonometrical expression. And you can see clearly that A comes first. That means algebraic comes before trigonometrical. And therefore, we shall let u to be x. Immediately, you look for du dx, which comes to 1. And then it automatically implies that dv dx becomes the other function, which is sine x. And it means now v becomes the integral of sine x. And when you integrate sine x, you get negative cos of x. So now we have u and v, we have dv dx, and we have du dx. That means we can now conclude by saying integral of x sine x with respect to x is equals to uv, but remember our u is x, v is negative cos x, so I'll write cos x here, and then a negative can be there, minus integral of v, which is negative cos x clearly here. Du dx is 1, so cos x times 1 is just cos x. The negative will go out to make this a positive, and then we have dx. So from here it means we are having x, which is a negative cos of x, plus, when we have the negative come out, we now have plus integral of cos of x dx. And when you integrate cos x, you remember we get sine x, and therefore our final answer for this question becomes negative x cos of x plus sine of x, and then plus an arbitrary constant of integration. So that is how we basically do this integral. The next example is we find the integral of x cos x with respect to x. We shall still use Laerte, and that means definitely in our solution we shall let u to be x, du dx becomes 1. dv dx definitely becomes cos of x, and then that implies that v now becomes sine x. That's when you integrate cos x. When you integrate cos x, you get sine x. So from there, we again use our formula for integration by parts. That means we shall have integral of x cos x dx becoming uv, but our u is x, v is sine x, minus the integral of v, which is sine x. Du dx is 1, so putting a 1 times sine x is as good as having sine x. So from there we shall have x sine x. When you integrate sine x, remember I told you, you get negative cos x. So a negative and a negative we shall have here will definitely end up a positive, but then we can first have it as that plus our constant. Then in our conclusion, integral of x cos x dx can now become x sine x plus cos of x plus a constant of integration. As simple as that. Let's look at example number 3. When you look at example number 3, it says we find integral of x squared sine x with respect to x. So what we need to know is that still x squared is algebraic, sine x is trigonometrical. From the word laity, algebraic comes first. So we shall let u to be x squared, du dx becomes 2x. dv dx now becomes sine x, but then v becomes the integral of sine x. V becomes the integral of sine x, which is negative cos x. From there, we apply the formula of integration by parts. So it's going to be integral of x squared sine x dx is equals to uv, but our u is x squared. V is negative cos, so I can have a negative there, cos x, minus integral of v is a negative here, cos of x, but then we have du dx this time round as 2x, so we shall have 2x there. Maybe we can make it clear, that we have a negative, then we have a 2x, and then a cos x dx. What you will realize and appreciate is that after us having the negative come out, shall have a positive. You can even pull out the 2 because it is a constant. We remain with integral of x cos of x dx. But then you need to remember very well that now integral of x cos x dx expects us to go through the same process of integration by parts for the second time. So I will say for integral of x cos of x dx, we shall let u to be x. That means du dx becomes 1. We go on and say dv dx is cos of x. That means to get v, we integrate that. So it implies that v becomes integral of cos x, which is positive sine x. And then we now say integral of x cos of x dx is actually equals to uv. Our u is x, v is sine x minus integral v, but our v is sine x. du dx is 1, so 1 multiplied by sine x is the same as sine x with respect to x. So at the end of the day, shall have x sine x, and when you carefully integrate sine x, you get negative cos x. With this negative we have here, the overall result becomes positive cos x. And then we can add our constant of integration. So we can now conclude that therefore integral of x squared sine x dx is actually as good as, we come back here, get our result first. We had negative x squared, we had cos x, and then remember we had a plus 2 into this integral which we have just worked out. So it is going to be 2 into brackets x sine x plus cos x, and then our constant can still be there, and that becomes our final answer. So we clearly see that for you to integrate x squared sine x with respect to x, you are going to go through the process of by parts 2 times for you to come up with the result. The same thing happens with integral of x squared cos x with respect to x. And that means if you had x cubed, it means you would go 3 times. But then later on, I'll talk about the basic technique that can as well help you to have that in the shortest time possible. So let's look at example number 4. So example number 4 tells us to find integral of x exponential x with respect to x. So again, from here, when you use the word Laertes to guide you, you will realize that this time around, we have an algebraic expression, which is x, and then we have an exponential function, which is this now. So algebraic comes first, and therefore we shall still let, in our solution, we shall still let u to be x. That means du dx is equals to 1. dv dx definitely becomes exponential of x, and v becomes the integral of exponential x, which is the same as exponential x. So from here, we now write the formula. That means x exponential x, the integral of x exponential x with respect to x becomes uv. U is x, v is exponential x, minus the integral of v, which is exponential x. Then du dx is 1. So 1 times exponential x is just exponential x, and then dx. So the final answer clearly becomes x exponential x minus, when you integrate exponential x, you get the same exponential x, then plus our constant of integration. So there we are. There we are. So that becomes our final answer. Now, I want you to give a try to number 5, which is going to be find the integral of x squared exponential x with the respect to x. The only difference you will appreciate here is that you will also go for integration by parts 2 times. You will go for it 2 times. And you will find the answer easily, just like we did in the previous question. I can still take you to question number 6. Okay, so number 6 now happens to be an inverse trigonometric function. What we need to still appreciate here is that we have a silent one. Here, which is as good as x plus 0. So we shall treat it as algebraic, and then we follow the order of Laertes again. Now, this time around, you realize that inverse trigonometric function comes first before algebraic, and that means we shall strictly let, in our solution, we shall strictly let u to be tan inverse of x. Shall let u to be tan inverse of x, so that du dx now becomes 1 divided by 1 plus x squared. In case you find any issue with this, you visit one of my videos that was talking about derivatives of inverse trigonometric functions. It is clearly explained. And then from here now, we know that v is, the v dx is definitely going to be 1. And that means v becomes the integral of 1, which becomes x. Remember, we are integrating 1 with respect to x, so it becomes x. So our answer in this case will be integral of tan inverse of x dx is equals to uv, but u is tan inverse of x, and then v is x, so we have x tan inverse of x, minus integral v, which is x, du dx is 1 out of 1 plus x squared dx. And then now to integrate this function here, you realize that we have to use the change of variables. So you simply let u to be 1 plus x squared. Should you differentiate it, you will get 2x. Make dx the subject, and then proceed normally, and you will realize that when you do so, our final answer becomes x tan inverse of x here minus. Now the integral of this, if you carefully follow that procedure, you are letting u to be 1 plus x squared, du dx becomes 2x, dx becomes du out of 2x. Go back to the substitution, x divided by 1 plus x squared dx now becomes integral of x divided by, this is now u, dx becomes du out of 2x. The x will cancel, so you will realize that you have a half out, integral of 1 over u du but integral of 1 over u is natural logarithm of u, so it means we shall have a half ln of u plus a given constant. But remember our u is 1 plus x squared, so the answer comes to a half natural log of 1 plus x squared plus a given constant c1. So I can comfortably write that answer here as a half natural logarithm of 1 plus x squared. So this is how easy it is to handle all these cases. And I think I can now give you a few questions to try out as far as integration by parts is concerned. Okay, so this is our simple exercise. You give it a try. In case you get any issues, you check on me through WhatsApp or through my email. And then don't forget to subscribe to this channel, because if you do so, you will never miss out any upload I make at any time. You will be updated. And then also don't forget to turn on the notification button. See you in our next tutorial. Bye-bye.